So in the last section we talked about selectivity, and that's where the halogen gets placed, which carbon. Now we're going to talk about the stereochemistry of that placement. If we have a halogen that creates a new chiral center, because the intermediate is trigonal planar, it can be attacked from the top or it can be attacked from the bottom. And because of that, you will get both the R and the S formed. It'll be racemic. So here's our example. We have our alkane, and we're treating it with chlorine light, give it some energy, and we'll get a chlorine in this position coming at us, and we'll get a chlorine going away from us. And that's because we've made a chiral center here. New chiral center. We have 4 different things attached at that particular carbon. We will also get, oh, I keep wanting to do that. There we go. We'll also get a chlorine on the end. So we're going to get all 3 forms. If we do a halogenation at an existing chiral center, we'll also get a mixture of enantiomers. Now here we're doing bromine, and so we won't expect to get any, we'll expect all our bromine to be added to this carbon because this is going to give us the most stable reaction intermediate. But the intermediate is going to be trigonal planar again, and it can be attacked from the top or it can be attacked from the bottom. And so our result will be, and we can get the bromine coming toward us and the methyl group going away, or we can get just the reverse. The bromine going away and the methyl group coming toward us. You can also get diastereomers. If there's an existing chiral center, but it's not involved in the process, you'll get a diastereomer. So this is a chiral center, and it's going to stay a chiral center. So it's here and here. It hasn't changed. But when we add our bromine to this loci, that carbon right there, we add a new chiral center. So this compound has 2 chiral centers. And so they are diastereomers to each other. So let's predict the stereochemical outcome of radical bromination to these compounds. First, we need to pick where that hydrogen is going, where the bromine is going to go. And it's going to go on this carbon right here because that's going to make a tertiary radical intermediate. Okay? And so we've got, now the question here we want to ask ourselves, have we made a new chiral center? And we actually have not, because we are the same going this way as this way. So those are identical, and so this is not a new chiral center, so we don't need to indicate any stereochemistry. But let's look at this next one. Here, we're going to add our bromine to this position. That'll give us the tertiary radical intermediate. And this is not going to be, they're not the same. So this will make a new chiral center. Because we are not the same this way as this way. Okay, so what we'll get will be a racemic mixture. And in And some of them, the methyl will be going one way, and then let's look at the third one. We're going to add to this carbon right here, and we're going to end up making a chiral center again, so we'll have two different forms. And we'll have methyl group coming toward us, the methyl group going away from us, the bromine going away, the bromine going toward.